All right, one of the questions that students must answer as far as UTME is concerned, that's Unified Tertiary Matriculation Examination, and also WAEC, one of the questions that students must answer is a question that is based on chemical equilibrium, and that's why you must know chemical equilibrium. Welcome to Chemistry Meal. Today on Chemistry Meal, we are looking at chemical equilibrium part 4. Right, we have looked at part 1 where we considered the meaning of chemical equilibrium and the characteristics of a system that is in equilibrium, and we also looked at part 2 where we considered Chatelier's Principle, and then in part 3 we looked at the effect of temperature on a system that is in equilibrium. And in this part 4, our business will be to consider the effect of concentration on a system that is in equilibrium, and after that we move on to see the effect of pressure. Maybe that will be in part 5. All right, just get ready. Let's enjoy chemical equilibrium together. All right, let's begin. Okay, so effect of concentration on a system that is in equilibrium. So effect of concentration. Effect of concentration on a system in equilibrium. So effect of concentration on a system that is in equilibrium. Okay, how does concentration affect a system that is in equilibrium? You will remember that for a system to be in equilibrium, that system must be reversible. Yeah, we said that under the characteristics of what? Of a system that is in equilibrium. So, and because it's reversible, a constraint will either move the equilibrium position forward or move the equilibrium position backward. In other words, the equilibrium position can shift to the right or it can shift to the left, based on how the constraint is being introduced to a system that is in equilibrium. So what is the effect of concentration on a system in equilibrium? So quickly, increasing the concentration of reactants will shift equilibrium position to the right. Thus, equilibrium position to the right. Thus, the forward reaction will be favored. So when we increase concentration of reactants in a system that is in equilibrium, for a system that is in equilibrium, definitely the equilibrium position will shift to the right. So increasing concentration of reactants will shift equilibrium position to the right. And we know that when equilibrium position shifts to the right, the forward reaction will be favored. So, and we also know that when we say that the forward reaction is favored, it means more products are generated or more products are formed, meaning that more reactants will be used up. So this also implies that more products are formed or more reactants are consumed, or maybe more reactants are used up. So when a system shifts, when the equilibrium system shifts to the right, it means that more products are formed. That means that the forward reaction is favored. Yeah. In that case also, we can say that more reactants are used up or more reactants are consumed in the process. So increasing the concentration of reactants will shift equilibrium position to the right. So when we want the equilibrium position of a system, a chemical reaction system that is in equilibrium, if we want it to shift to the right, or if we want the forward reaction to be favored, then we need to do what? we need to introduce more reactant. That's, we need to increase the concentration of the reactant. All right, what will happen when we decrease the concentration of the reactant? Definitely the opposite will now take place. So decreasing the concentration of reactants will shift the equilibrium position to the left, thereby resulting to less production or less formation or less generation of the products. So in this case, the backward reaction will be favored. So in this case, the backward reaction will be favored. The backward reaction will be favored in this case. So less reactant will be used in this case. Less generation of products means what? Less reactants will be what? Used. We will not use much reactant. Less reactants will be used because the backward reaction will be what? Will be favored. So when we decrease the concentration of reactants, the equilibrium position will shift to the left, sorry. Increasing the concentration of reactant will shift the equilibrium position to the what? To the right. Now, the question is, how can we increase the concentration of reactants? So let's note that. Let me just say note. Concentration of reactants can be increased, one, by adding or introducing more reactants. Or two, by removing the product as soon as they are formed. So if we want to increase the concentration of reactants, we can introduce more of the reactants, or we remove the products as soon as they are formed. So as soon as you are forming the product, you are withdrawing the product. That's another way of doing what? Increasing the concentration of reactants. So we have said that increasing the concentration of reactants will shift the equilibrium position to the right. Thus, the forward reaction will be what? Favored. And this means that more products will be formed and more reactants will be used up, or more reactants will be consumed. But when you now decrease, the reverse will happen. Less products will be formed, the backward reaction will be favored, and less reactants will be what? Will be consumed. Now let's look at this. Now let's look at this together. If we have considered this reaction, so if we look at this reaction, let me just explain this way. Let's say that X reacted with what? Y to give us Z, right? This is a reversible reaction. We know that once for a reaction to attain equilibrium, that reaction must be reversible. We saw that under the characteristics of what? Reactions in equilibrium. And we mentioned other things like catalyst will not have effect on it. It must be on a closed system. And there are other things that we mentioned in the process. Okay? So if we look at this reaction now, X reacting with Y to give us what? Z. X reacting with Y to give us Z. Now, if we look at this reaction, if we begin to introduce more of X here, you will see the equilibrium position will shift to the right. Because if we are introducing more X here, it will make X to react with what? Y, leading to generation of what? Of Z. So increasing the concentration of reactants will do what? Will make the forward reaction to be what? Favored. Now, another way, apart from introducing more of X or more of Y, in order to shift the equilibrium position to the right, that is in order to increase the concentration of the reactant. Another way of increasing the concentration of the reactant is to remove the product. Once you form the product, you take it away. Imagine when this and this combine to give us Z. As we form Z, we remove it. So here will be empty. This and this will be forced to react again to replace the what? The Z. So we can increase concentration of the reactant by introducing more of the reactant, that is adding more of X, adding more of Y. We can also increase the concentration of the reactant by removing the what? The product once they are formed. Once you form the product, we just remove them once we form the product. Alright, so that's the effect of concentration on a system that is in what? In equilibrium. That's the effect of concentration on a system that is in equilibrium. We can also use a football pitch as an example. Okay, let's describe this using, let's explain this using football now. Now, if you have the stadium, right? Let's see what happens. So for those that don't love football, just pardon me. Okay, we can just draw the pitch anyhow, right? So that we can explain this. Okay, so this is the center. Now you have two teams. We know you used to have 11-11. Let's say team circle. So I have this. Maybe they are playing 4-4-2 formation. We have this team square. Let's say I have team square, team circle and team square, or team rectangle, whichever one. Team square or team rectangle. So we have this. Let's say they are playing which formation now? Don't mind me. Maybe 3-5-2. So this one maybe 4-4-2, and two persons here. Then maybe these ones are playing 3-5. and 2. Now you see this. Now the concentration of team circle is equal to the concentration of what? Of team rectangle or team triangle. That's the goalkeeper, the defenders, and the rest. Okay, so now imagine if we're just playing the football normally. Supposing we decide to add 2 more persons here. Instead of 11 against 11, right? We now have 13 against 11. What do you think will happen? You notice that more of the ball will be going towards this side. Why? I just increased the number of players here. So they will have more of the possession. So they will be pressing these people. More of the ball will be moving here. So these people are just like the reactants, team product, right? So if I increase the number of people on the reactant side, on team reactant, maybe I added 2 more players. Instead of 11 against 11, we now have 13 against 11. You will notice that the ball will be moving to this side. You see, the forward reaction here will be what? Favored. Another thing that can happen here is that, supposing in the course of the match, you now notice that someone was given red card here. They gave 1 person red card, and they reduced to what? Now 10 players. That's including the goalkeeper, 10 players. Now I just remove 1 person from the team product. That will also make, if you watch football, you notice that once a particular team is 1 man down, you notice that the other team will start pressing them. So more of the ball will start going here. Why? One of the players have been removed. The player has been removed from this place. So you now see more of the ball. The ball will be going towards this place steadily. Because of what? We just increased the reactant. How did we increase the reactant, team reactant? By removing 1 person from the team what? Product. So the same thing will happen if we reverse it. Imagine if these team products, they are complete, and we just remove 2 persons here. Definitely more of the ball will be going towards this side. So that explains the effect of concentration on a system that is in what? Equilibrium. Yeah. So the more the concentration of the reactant, the equilibrium position will shift to the what? Right. If you decrease the concentration of the reactant, the equilibrium position will start shifting to the what? Left. And we said we have two ways of actually increasing the concentration of the reactant. One of them is to add more reactants. But you know, this one will not be permitted in football. We cannot add two persons here. Football is 11 against 11 and not 13 against 11. So in this case now, one of the ways is, let's give this person a red card. We will leave the pitch. So one of the ways of increasing the concentration of the reactant will be to remove the product as soon as they are formed. So if we remove one person here as a result of red card, we have actually increased the concentration of the reactant, and that will make the equilibrium to move more to the what? To the right, favoring the forward reaction. If we do the reverse now, removing one person here, then the equilibrium will now start moving to the what? To the left. Okay. So that's the effect of what? Concentration on a system that is in equilibrium. Take it again. Increasing the concentration of reactants will do what? Will increase the generation of what? Products. That means the forward reaction will be what? Favored. But when we decrease the concentration of reactants, then the volume of product or the mass of product or the amount of product that will be produced will be less, meaning that the backward reaction will be what? Favored. And in that case, we say that less reactants will be used. But when you increase concentration of the reactant, more reactants will be used, equilibrium will shift to the right, more products will be formed. If you reverse it, less reactants will be used, less products will be formed, and the equilibrium will shift to the left. All right, in our next video, we're going to look at effect of what? Pressure. And after that, we'll return to take equation to show the effect of temperature, the effect of pressure, and the effect of what? Concentration on a system that is in equilibrium. Don't go anywhere, because I will be back. Remember, I'm your friend and your tutor, Engineer Ike. I love you.